Just, I handed out a copy of one of the tests. That are out of the set of 15 or so that I ran, and put the other 14 in the testing center. The tests are randomly generated, so that what you see in this test is not what you're gonna see on the test you take, but it will have the similarities. I handed out a set of the problems from which the test was gonna be generated. The types of problems, the numbers will vary. So you should be pretty well aware of what's going to be on the test. I'm going to give you a real quick synopsis because we're into the open math assignments now. Okay. And I will comment that only a couple of people did the assignments. You really have to do those assignments. You're going to need the points. And even more than the points, because the points, points will, if you don't do the assignments, you're going to lose letter grade. No points for that, but that's about it. If you do it, then it might raise you a letter grade, depending on test scores and so forth. But the points are less valuable than the knowledge you gain. So make sure you're doing them honestly. You don't just sit there with an example and copy down what the example did. You learn how to do the problem by looking at the example, put the example away and do the problem. Okay, then if you can't, maybe you look back at the example again because you want the points, but at least you've engaged your brain on the process. And then when you come in here, we're going to start having a quiz every day over what you did on the homework. See if you learned anything. Okay, so you're going to have to do it in such a way as to learn. I gave you through yesterday to get the first two assignments done for full credit. Okay. I haven't looked at the half credit page to see how many people have enrolled themselves in that page. But if it was done before midnight last night, I'll transfer the grade over for full credit. Okay. I looked last night, but it wasn't late last night, and I know most people do things late, last minute and all that stuff. I never did that myself, except most of the time. And as I totally understand, it's not the best way to learn. But sometimes it's just the way you manage your time, and that's the way it works out. So whatever, do what's necessary. As far as the test goes, you notice the front page where you have to put your name on it. Okay, don't put your name on it. You just miss the test. And no outside notes, learning aids, or any other information. Can't even bring your phone for the calculator. You can't even bring your own calculator. Because people could put most of human knowledge on a modern calculator. Okay. And maybe even sneak one in that has internet access. So yeah, we don't allow your calculator, but there's a Casio FX 260 that they will allow you to use for the test. You should make sure you know how to use it. You should go over there before you take the test, make sure you know how to use that calculator. Most people do. I've not seen any problem people have using the calculator. So there's no time limit. You've got to complete the test in one sitting. And then something went haywire with the page break, but it says work, and then on the next page, work the problem on the given sheet and so forth. And then every sheet says work the problem on this given sheet. Sometimes the given sheet doesn't leave, it has a long problem, like this first problem here, only gives you this much room on the sheet. I don't want anything in the back. Use test center scratch paper and insert it between the sheets. Don't put it at the end, although if it's at the end, I will find it eventually. But as much as possible, work the problem on the page where the problem is stated. Okay, all this is pretty straightforward. So I'm just going to give you a really quick synopsis. I posted a video 2 weeks ago with a pretty complete synopsis of what you need to know. And I think the total watch time I see on that video is about 1/3 the length of the video. That's everybody that watched it. Okay, people are not watching these videos, which is okay if you're learning it. You don't really need the videos if you come to every class or follow up in class with class videos and do everything you're supposed to do, okay? And you don't really need them if you're really pretty good at picking this stuff up quickly and follow what I've been telling you. But for the most part, people really kind of need those videos. So this is going to be as quick as possible. So you're going to have to understand my words. I'm not going to write things out in detail because we have other things to do. And we've done it already. But this is last minute, quick thing. Okay. You know how to divide rectangles. Every line being twice as close to the center as the one before it. Here, every line being twice as close to the lower edge as the one before it. Until you get the right number of lines to make the graph that you're trying to make. And you should know how many lines it's going to take because you should have drawn these things at least a dozen times a piece by now, maybe more, because it doesn't take long to draw one. If you haven't spent a couple of hours doing it, it's either because you don't really need a couple of hours because you understand it, or because you haven't done what's required. Okay, because what's required is that you be able to draw these graphs, and some people will learn it faster than others. You should also be able to label the construction lines. You should know where the red dot is. There's one type of graph. There is another type, which looks like this. You go to the center, you divide it up. For the exponential function, that's all you need to do. For most of the other functions, you need a couple of divisions. You need 5 lines in the middle. Now this helps you for the exponential function because this one is going to divide up toward the center. Here I divided it with horizontal lines toward the bottom. Here I'm dividing it with horizontal lines toward the center. You should understand what that means. In this case, the red dot goes here. You construct the graph. By its algorithm. Which is where to start. How far over, how far up or down. I don't have room to write how far up or down, but everybody should know that. That's how you locate the points. And it's got to end up where it's got to end up. If you follow the algorithm and you don't have quite enough vertical lines, let's say, for around the exponential function, you might end up here. Well, you should know we're going to end up here. Okay. And so forth. This is the exponential function for any function. You need to know where these graph sets start, where they end up. You need to know their domains and ranges. I don't remember if I tested over the domains and ranges, but we've explained it. Okay. So you can look at the test. I kind of think I don't. But handout I gave you a week and a half ago tells you everything you need to know. Okay, I mean, gives you examples of everything I can possibly ask you. Okay, so make sure you can answer those questions. So you do this now. function is g of x equals a times f of x minus h plus k. H and k are the coordinates of this thing, so you just plug them right in. Now you gotta know how to substitute into the function. It's x squared for the square shape, 1 over x, 1 over 4, 1 over 4 times 1. For the reciprocal shape, due to the x, for the exponential, 1 over x squared for the reciprocal square, and x cubed for the cube. You have to know how to plug in x minus h for x, then add k. For this test, a is always 1. A is needed. There are rules for what you can do with a, and we'll get to those like first of next week. And we'll build what we're learning in open math. Oh, buoy. Not sorry to use strong language. I meant, no, I don't want to say that one. Okay. Sleeping camera will not stay in focus. And it doesn't have a manual sleeping focus. Okay. Hey, don't laugh out loud. You can be identified. No, I'm kidding you. I don't think we're gonna identify you by your laugh. Here's a pretty generic laugh. No offense if you think you got a really unique laugh. You can laugh out loud. It's okay. If you want to be really unique the way you laugh, just develop one, work on it. Okay, now, seriously, this computer is supposed to be replaced tomorrow. And I'm going to replace this camera with that camera, which won't work with this computer because it has to go through the network, which makes it impossible. They've done some improvements in the network. This is going to be good, assuming I don't get locked out of the network for the next 3 weeks when they try to change things. So we'll see what happens. Should go smoothly. They're confident. They've done almost everybody else. We saved the best for last. Yeah, mine's a little more complicated. Okay, now. Okay, I think everybody should understand what I just did. But again, here's how you line things off. Here's where the red dot goes if you approach the, if you subdivide toward the lower line. Here's how it looks if you subdivide horizontally toward the center. Vertically, it always looks the same, except the exponential function doesn't leave these last 2 lines. Okay, and you don't want those last 2 lines for doing the exponential function, because then your points aren't going to come out right. All right. That's a lot of what you need to know. Now, of course, you need to be able to make estimates. You need to be able to label your construction lines, which really helps with your estimates. Okay. One thing people had trouble with, we went over it quite a bit last time, but let's just repeat it. Given the occasional red dot, label the bounding lines, because if you don't label the bounding lines, you're going to have trouble figuring out what the construction lines are. Okay, so here you got a red dot. Here's H, K. And here's a rectangle. Okay. So what are you gonna do? Now, this vertical line is an x equals line. We've established that. I asked you to sketch a set of coordinate axes, then 3 points with x coordinate 5 or whatever. And everybody put 3 points vertically above each other and understood that then that made sense to call that the line x equals 5. Don't remember that? Go find it in the videos, review it. Okay, and similar for horizontal lines. So everybody understood short term that a vertical line is an x equals line because every x coordinate is the same on this line. I think most people understand that anyway, but I think there's some people maybe still need to think about it. And here, x equals what? Well, how are you going to get it? If this is a 4x4 rectangle, then the distance here has to be 2, and the distance here has to be 2. So x is going to be 2 more than h. So if h is 12, that's got to be 14. And this has got to be 12, not 10. Because 12 is halfway between 10 and 14. Now, it's all 4x4. Now, next week, I'm going to lay some on you that aren't 4x4. Okay? And we saw one on the cubic function. Okay? So when you do the cubic function, you know they're not always 4x4. Okay, so we spent some time on that last time. So if you don't understand that, make sure you do. Okay, and then you got y equals what? And y equals what? And then you've got your construction lines to later. And so on for all of them. And your construction lines for vertical. Obviously, the middle ones be x equals h, whatever h is, because that's the x coordinate at this point. What's this one? What's this one? What's this one? What's this one? You can memorize that this is 1 more than h, and this is half more than h, but reason it out because you're going to have to reason it out next week when I don't give you 4x4. If this is 7x4 or 7x12, you know, then what are the numbers? You got to figure out what numbers halfway between two numbers. We'll talk about that. Okay. One of the purposes here is to get you used to the coordinate plane in a way that people almost never are when they come into a pre-calculus class or when they go out. We want to establish this because it makes the rest of the course a lot easier and it gets retained better and you get to apply it better. Okay. So, and of course, if the red dot is in the middle, then you gotta be able to say again, you know, what are your bounding values? Or if I give you the bounding values, figure out where the red dot is, right? Okay. Now, people had a lot of trouble with this. We're seeing the numbers. So make sure you see the numbers. Okay. Now, if I give you the bounding values, okay, then what are the coordinates of the red dot? Where's the rectangle? If you're given the bounding values, and if the x's are 4 units apart, the y units will probably be 4 units apart as well, but not always. Okay. Then what are the coordinates here? Well, the x coordinates halfway between these. Right. If it's 4x4, you still have 2 units here and 2 units here. So you know what x is here. You can figure out what x is here. And if it's a 4x4, or if it's an 8x4, Okay? Then y is gonna be that much more than whatever it is here. The y coordinate here is gonna be the same as whatever it is on this line. So you're gonna be able to figure out all your construction lines from the equations of these bounding lines. Well, you've been having problems like that for 3 weeks. Okay, if you've done the homework, which almost nobody's done, at least I haven't seen it. And haven't seen a lot of evidence that's been done. You have it. You can still put this together. It's not that hard. We're gonna have to hustle a little bit to do really well. Okay. And of course, you have the same thing here with the red dot in the middle. Okay. Then why wouldn't it be here or here? It'd be halfway between here. So you need to be able to do that. If you do those things, then you have a foundation for being able to do pretty much everything I ask you to do in the test. Okay. Now, everything that I ask you to do in the test has been done in class, except there's one problem. It either talks about, what does it talk about? It either talks about the value of an investment, which is on an exponential curve. So it tells you to sketch an exponential curve in this window, in this box, and make some estimates. Okay. And the other one is how far something travels if it's rolling down a ramp. Okay, and that has the shape of a squaring graph. Just the right half goes like this. This is how far you go. This is how long you've been gone. So you go faster and faster. So the curve goes, curves up and up. And I asked you some pretty straightforward questions about that. And there's a video that is posted and has been posted for a couple of weeks. It's a 15-minute video. You should watch it. It's not a hard problem. But if you don't watch that video, you're probably not going to get it. Okay. 15 minutes and you will probably understand enough to do that problem. Okay. Now I did say not everybody's necessarily here. And don't remember when I said it. But the problem where you're supposed to draw the 5 graph shapes in a box might not be on the test. It should have been. Something about that problem. I haven't investigated the test. I might be able to fix it when I investigate it. But for some reason, the program skipped over that problem or something. Something happened. So there's something missing. Okay. And if it's that problem, make sure you do it on a piece of testing center paper. Just sketch the 5 graphs and tell me which one's which. That's all there is to it. I'll send an email out about that too, because not everybody can make it today. Okay, that's all I'm going to say about the test. We've got to talk about open math. And everything we've done so far, if you've mastered it, should give you much deeper insight into what we're doing in chapter 1. Okay. Even if you've done half of it, you should have quite a bit of insight. But the better you've done, the more insight you have, and the easier it's going to be to understand what's going on. Okay. Talked about domain and range last time. And we talked about functions. If you've done the problems and you understand the notation better, then you should already have understood it by doing the exercises we've done so far. Okay, so that what you learn in the open math just enhances what we've done, and what we've done enhances what you see in open math. So it just kind of riffs on the topics that we've touched on. We've touched on topics that cover a whole lot of the course, actually. And they should make the whole course much smoother. But there's some algebra involved. So just a couple more examples to review a little bit what we did last time, that you should be well aware of it by now, having done it all. Okay, so if we have y equals x plus 7 over x squared minus 4. What's the domain? I'm not going to ask you about the range because it's later on in the course when we learn to graph a function like this, and you can see the range. Okay. And there's some complications in graphing, and it's much harder than graphing the functions that we've done. But if you've done the functions we've done and really understand them, then you can make a whole lot more sense out of what the graph of this thing looks like. Okay. So the question though is, what's the domain? Well, that'd be all real numbers because the denominator can be 0, right? And we can't include the values of x that make it so. Okay, well, denominator equals 0 means x squared minus 4 equals 0. Now, can you show me with your fingers a number that makes that 0? What value of x makes x squared minus 4 0? Yeah, x is 2. 2 squared is 2 times 2, which is 4. 4 minus 4 is 0. So by inspection, in this case, we can see that x can't be 4. Can't be 2. Okay, can't be negative 2 either, because if we square negative 2, we're going to get 4. Now, what I'm telling you right now is really critical. So if you don't totally understand it, go back to the video, make notes, drill it into your brain, whatever, because you're going to see the issue again and again. And if you really get it now, it won't be a stumbling block later. Okay? Well, clearly x could be 2 because 2 times 2 is 4. 4 minus 4 would be 0. X could also be negative 2 because if you square negative 2, you do negative 2 times negative 2, which is positive 4. And you get 0. Understand every word. Okay, please. Now, formally, we solved this equation, and we should all know that you got x squared minus 4. You can add 4 to both sides of this equation. And you get then x squared equals 4. And the solution to x squared equals whatever is x equals plus or minus the square root of whatever you've got here. And the square root of 4 is 2, because 2 squared is 4. But it could be plus or minus because when you square, if it's minus, you multiply it by itself, that'll be 2 negatives, it'll be positive. So it's plus or minus 2. So we exclude 2 and minus 2 from the domain because the domain is a set of all x values that we can put into this without blowing up our calculator, without blowing up our brain by having to do a limit toward infinity. Okay? Remember being curious about infinity when you were 10 years old? Anybody remember that? I got a 10-year-old grandson who keeps asking me questions about infinity. And he's not doing great in school. He's dyslexic, he's got some catching up to do and stuff. That's okay in his math. Yeah, pretty soon he'll get so deep into his video games that he'll forget that infinity is a fascinating idea. And he'll become a little more deficient. But his dad is a big, strong, amazingly, think the Rock. But a couple of years older and 20 pounds lighter. Okay. Yeah, Rock minus 20 pounds is still intimidating. And there's plenty of martial arts, black belts and stuff. His dad will prevent some of that. And in a nice way. So it's kind of interesting. Anyhow, that's good. And my daughter too. I mean, she's actually. Hopefully he won't descend too far before he starts his upswing again. He's approaching the age where the descent is pretty rapid. Most people. And think back to your own past. Okay. That's why I mentioned it. He's 10. Seems like 2 weeks ago he was born, and seems like 2 weeks from now he'll be 20, and I might not even be here. Good chance I won't. Just statistically, 10 years under my age gets me at 100. And, I don't know. Okay. Now, back to this. Infinity is an important idea. Okay. We've already experienced it. You keep going twice as close to zero and twice as high, you approach infinity, don't you? That's what happens when you construct the reciprocal or the reciprocal square function. It goes up even faster. And you keep going closer to zero, and keep going closer to infinity, and that's got a lot to do with what happens when we try to graph this function. Which is why we want to understand its domain. And it can be an important function. Okay. And it's not hard if you get everything up to that point. If you don't understand the solution of this equation, if you don't understand why we exclude 2 and negative 2, if you don't understand why we don't divide by 0, which we've explained a couple of times in terms of what happens when you go to 0 and the thing blows up. Okay, you never get to 0, can't use 0. So you kind of think about that. Okay, anyhow, we exclude 2 and negative 2 from the domain. I'm just trying to make the point that domains are important. So the domain is the set negative infinity, negative 2, union the set of the interval from 2 to 2, union with the interval from 2 to infinity. And these are open intervals, so that negative 2 isn't included here, and it's not included here. So it's not included in your domain. 2 is not included in this interval, 2 is not included in this interval, so it's not included in your domain. And infinity or negative infinity can't be included because neither of these things is a number. Which again is something you need to grasp, especially if you're going to take a calculus course. Because you have limits that are infinite, and you need to learn what that means. And this is pre-calculus, and we're talking a little bit about it to hopefully get the idea beginning to wire itself in your brain. Okay? Okay, so understand the example? Should. If not, go back and make sure you understand it. You can skip all my raving in between, but make sure you understand the example. And it simply that this can't be zero because you can't divide by zero because that gives you something that approaches infinity, sort of. So that x squared minus 4 can't be zero, therefore x can't be plus or minus 2. And here's how you solve the equation. And we exclude 2 and negative 2 from the domain, leaving you this domain. All right. Not going to talk too much about range. You really kind of have to have the graph to do the range, but you should be able to answer the questions that are being asked in the. If you got a graph, and there are problems in the homework that have graphs, okay, and they look like this. If you include this point, you don't include this point, where's your domain? Well, your domain is set of all your x values. They start here and include this point. They end over here, but they don't include this point. So right here's your domain. And your range. And you can see it on your graph, so you can just write it out. People that have done the homework have sometimes missed this. Okay. Now this goes along with what I've done a few times in class, so make sure you understand it. So you get that homework. Makes these problems really easy. Okay, now the range, you just take every point on this graph and do the horizontal line. Now, so far, we haven't gotten any values of y that we didn't already get as we went from here down to here. But now here we got a few new ones. So we got a value here, and a value here, and a value all the way down to here, but not quite down to 0. And this value of y occurs at the low point of the graph. And the graph is a smooth continuous graph, so this point is going to be included in the range. Now, if this was the lowest point, it wouldn't be included in the range. Or if the highest point had a circle on it, or the lowest point, okay? But if there are points below it, then this point is included in the range, because if I draw a line from here over, it hits the graph, and we got a line from there over here, it's in the range. Okay, so your range would be from here to here. Now, I've emphasized before that you should be doing your homework in a dedicated notebook, so you have a total record of your homework. Okay? I'm not requiring that, because I didn't put it in the syllabus. Okay, but I'm strongly recommending it. One way or another, when you come in, I want to see your written homework. I want you to write out your homework so that you learn it better. Okay? Write out what you're doing. You'll retain it better. You'll learn it better. You'll be more likely to have a quiz. Okay? Sometimes I'll even let you use your homework as a reference for doing a quiz. Most of the time I won't, because I want to see what you can really do. But sometimes there's, the nature of the quiz will be such that, yeah, it's only fair for me to let you look back at your homework. Okay? If I ask you hard questions. If I ask you easy questions that are identical to the type of questions you have on the homework, I'm not going to allow you to use the homework. I'll ask you to have it sitting there face down, so I can pick it up and look at it. And that allows me to see what you know and what you don't know. I'm not going to grade you on it. Whatever grade you get in open math is what you get, but I need to see what you're doing, and I need to see what you're thinking. So then I can talk about what I've seen, okay? And give you suggestions that might help you learn it faster, interfere with your life less, and learn it better, giving you a better grade. Okay, so So that's about all I'm gonna say about domain and range. We talked about last time, if you have a square root of something, then whatever's in the square root can't be less than zero. You got an inequality to solve. They're usually simple inequalities. And there's one problem in the homework where you had the factor your denominator. Okay. So I think there's a video along with that. And if you didn't get that one, it's not too much to worry about right now, but because we haven't really talked about factoring, but you really should know how factor. Probably. Okay. I agree too. If you don't, yeah, we'll hit it, but we'll hit it kind of briefly. Okay, now. I'll also say that all these topics I've done in the MDE 61 in a lot of detail. Go back to those videos and engage with them. By do, it says do this, do it just as the class did it, okay? And see how you did, and then see what I have to say. Because usually I'll talk about pitfalls that I see or pitfalls that I usually see, and if nobody fell into that pit this time, because I know it's important for people, okay? Okay. Rate of change. Now my paradigm example. If money flows into your account of $15 per hour, this is most likely because you're working during that time and the employer just kind of has this fancy setup where as long as you're working, money's flowing into your account. So during the hours you work, it just kind of flows continuously. Yeah, 25 cents a minute. Should be $15 an hour. So you can hear those quarters sinking into your account. Okay, or maybe it's a penny every 0.4 seconds. Okay. So it's almost continuous clicking of copper. Okay. So you have your money flows into your account at $15 an hour. We say that $15 is the rate of change of the value of that account with respect to time, assuming that you're not withdrawing money from your account, or your account hasn't been hacked by somebody who's slowly cleaning it out under your feet. Yeah, make sure you're secure there, but or spending money, maybe you've got subscriptions that take out a penny every 5 minutes. So you can use this software or whatever. But let's just say that nothing's going out of the account, then this is the rate of change of the value with respect to time. Okay. Now, if another account increases, I should say increases in value, but I won't write in value. And the way I'm gonna state it is, what's the rate of change? Now, that is something I abbreviate by ROC. That ROC stands for rate of change. This takes time to write out rate of change. We use it a lot. And WRT stands for with respect to. So tell me what you think the average rate of change of the value with respect to time would be, and write it down on your paper. If you're writing something else, stop for a minute and just off to the side or whatever, circle what you think the average rate of change would be. Okay, this is a pretty intuitive idea. But let me make a definition now, okay? Okay, it's delta y over delta x. Delta means change in, so this means change in y divided by change in x. Might be a little hard to read my x and y, that didn't come out very good. But, okay, so in this case, we know that its average rate of change of value with respect to time. Y is the thing you're doing the average rate of change of, x is a thing you're doing it with respect to. So y is value, so the thing comes before with respect to in the phrase this with respect to that. So y is value, x is time. The average rate is delta y divided by delta t. And since y is value and x is time, delta y is change in value, delta x. A lot of times we use t, but delta x would be your change in time, which is $100 divided by 5 hours equals $20 per hour. And $20 per hour isn't bad thing. You kind of live on that if you're not trying to support an extended family. Okay. And if you are, hopefully you got a few people in that extended family working, then you'd be okay. Okay. So. Make sense? Well, that's the idea of average rate of change. And you have problems involve average rates of change, and you always come back, if you're not sure what to do, to these simple examples. About it. How's this analogous to this example? And this definition. You can always come back to the definition. You identify what your y is and what your x is. Now, a lot of times, open math will say, what's the average rate of change of this? And they won't say with respect to what, but it's obvious what it should be with respect to, okay? So I disagree with our leaving out the word respect with respect to, because that becomes really important in calculus. Okay? Because sometimes you're doing what we call derivatives, which are just different quotients, taken to a limit of something with respect to one thing, and then maybe the same thing with respect to another thing. If you leave out with respect to, I think you're losing an opportunity to make really clear what this definition means. So there's another stumbling block you don't run into later. Okay? Now, that also be represented as that. And of course, there are problems where I ask you to do fundamental triangles. Yeah, I didn't mention that because I was going to mention that. Okay, so it's as if you have a graph. And maybe it's one of your graphs, and maybe it isn't. Let's say you got a graph that looks like this. And here's y, whatever y means. And here's x, whatever x means. And we say, okay, on this x interval, then let's say x equals 5. And x equals 15. What's the average rate of change of y? Well, you do need a scale for y. So let's just say that on this line, y equals 100. Okay. So draw this picture for me. And tell me what you estimate y is here. Still there. The value of y. Let me sketch this very quickly. Try to write down my words. Come back and get them from the video later if necessary, or one way or another. But I want to see a quick sketch of what I've got here on the board, and then I want you to fill in that unknown value of y, or that unspecified value of y as you see it on the scale of the graph. Okay, I want you to get that very quickly, and everybody did it when I gave you another minute or two to think about it. On my graph, this is a little closer to 100 than it is to 0, okay? But, you know, y is going to be between 0 and 100. So we'll say maybe y equals 60. If I want to get picky, I'd say y is about 63.2874 on this graph. Okay. Well, anyhow, yeah. Some of you kind of smiled. Yeah, that was really a ridiculous statement, wasn't it? Because obviously I can estimate it to several more decimal places. Okay, well, here we go. Okay. Now, what is the average rate? It'll always be the average rate of change of this with respect to this. Okay. It's change in y divided by change in x. Now, if you just write down the y values, that's not the change in y, because we're going from this point to this point. We're going from here to here because we're on this interval, right? This is your change in x. So from here to here is how much x changes, right? And that's just the distance between these two lines. So we could also say that that's this distance, delta x. And then the change in y, and I don't want to write the word change in, but be sure you're reading delta as change in, okay? The change in y is, well, y is 60, y is 100. The change in y would be here. There's a change in y. But I can write the change in y this way. Okay. Now I can write this. Or I can make this arrow and this arrow two sides of a triangle whose hypotenuse goes from this point to this point. So here's delta y. Well, delta y is the rise. Why do I call it the rise? Well, that's how far I have to go up to get from here to here. And delta x is the run. Now rise is obvious, run, well, you gotta say something, so we're gonna call it the run, okay? Now I'm gonna say, always make the run go from left to right. So we go from the leftmost point to the rightmost point, because you avoid confusion that way. But if you're careful about it, you could do it right to left. But you gotta make sure the arrows go head to head and you get the right sign on these things. In this case, with this picture, delta x, if we always go to the right, then delta x is always positive. Delta y here is positive because you're going up, but you could have a graph that goes down and delta y would be negative, right? Okay, well, the run. Now we can just see that from here to here is 10. So we don't necessarily have to write anything down, but we're going to write it down because it's easy to get it confused when it's not obvious what the numbers are. So we write 15 minus 5 in this case. And that's 10. The rise in this case would be 100 minus 60 equals 40. So that if we do it with a calculation, we're going to do 100 minus 60 because we subtract the first quantity from the second. And the run is going to be 15 minus 5, which is 40 over 10. And most of you didn't write out this calculation because the numbers were nice and round and numbers were easy to figure out, but they aren't always. So it's always good to know how you get these numbers. And that equals 4. Okay. In terms of the graph, this is rise divided by run equals 4. What's rise divided by run? Between 2 points of a graph, that's a slope between these 2 points. And it's the average rate of change of y with respect to x. So we put 4 here and we put a little box around it. Now I've shown you this in a couple of weeks. Okay. If I ask you to do this on some interval of x on the test and it's on there, I think you're going to have to do it. That's all you do. Just mark your 2 points, do a horizontal arrow and a vertical arrow that leads you from the left point to the right point. Calculate the rise, calculate the run. Do this and label it the way this triangle is labeled, as I very specifically said a couple of weeks ago. You want to do all that, and the reason I want you to completely label it is so that you reinforce the meaning, so that you can just think the meaning without having to go back and think, what's this? Yeah. You want to be able to understand the meaning immediately, okay? And that takes practice. That takes labeling. If you label it, you'll understand the meaning better, more quickly. So when you need it later, you'll have it. And when you need it in calculus, it'll come back to you. Okay? All right. Okay, so again, f of x equals x squared. What are you going to write down for f of h of x? Just going to take a quick glance, see how many people got it. Well, this should be instantaneous because how do we look at f of something besides x? H of x is replaced x. In other words, if we take this expression and replace all the x's by h of x, we're going to get this is what I get if I replace x by h of x, right? And that's what we're looking for. But if I'm replacing x by h of x, I got to replace x by h of x. Okay. And what do we do with x? We square it. So what do we do with h of x? We square it. Now we're going to have some parentheses because otherwise you might get confused about what to square. But there it is. Now, if h of x equals x minus 7, then what is f of h of x? Well, two ways to see this. F of h of x equals h of x squared as we saw. But now we have a formula for h of x, it's just plain old x minus 7. So this equals x minus 7 quantity squared, since h of x equals x minus 7. That makes sense? It should, because we've done it. We did it 2 weeks ago. Okay. This is how we get from our basic formula for our toolkit function to the formula g of x equals a f of x minus h plus k. Okay, it's like your x minus h. That means we just shifted this function 7 units to the right. So that's just a squaring function. With the red dot at 0, at the origin 0, 0. But we shifted 7 units to the right, so now the red dot is at 7, 0. Okay, it looks like the squaring graph.
Yeah, there you go. Yeah.
I'll just make that a quick reference. Okay,
No.
now there's some cautions about composite functions. If h of x was like the square root of x minus 7, then you wouldn't be able to put like 3 in for x, because you'd end up with the square root of 3 minus 7, which would be the square root of negative 4, which is not a valid value. So that the domain of f of h of x can't include any x values that don't work in h. Okay. Also then, we've got to exclude any x values that result in h being something that's not in the domain of f. Now, I said that quickly, and it takes a lot of sorting out. but we want to get the basic mechanics down before we worry about the fine points of the domain and range, but you're gonna see questions involving that as well. So if you go back to my statement, I'll repeat it, and then we're done, okay? X can't be anything that doesn't work in H of X, right? And X can't be anything that gives H of X a value that doesn't work in F. Okay? So I'm gonna write that down, but I'm just gonna write it down. If you want to file it up, you got someplace to go, I want to hold you over. It'll take me a minute to write it down. So if you want to stick around and listen, okay, but if you want to stop out, that's fine with me. Okay? You got places to go. You don't let me hold you up. So. We'll put it in terms of the domain. Can't be outside the domain of H of X. I.e. X gotta work. For H. And X can't result in an H of X value but ain't gonna work in L. Okay, those are restrictions on the domain of f of H of X. Again, we're not worrying too much about range because it's algebraically obnoxious until you have the graphs. And then you can see what the range is, okay? We'll do the algebra later, but I'm not gonna lay that much algebra on you at this point in the course.